Again, an interesting question. It's an exponential 2 to the x, and then you see it equals x to the 32. Certainly doing it without looking at a visual, proceeding as we did at the whiteboard, we got x equals 256. However, I do suggest graphing it out. Certainly if I were to graph it out, I would not have seen the 256. I would have seen one much closer to the origin. And the reason for that, x to 32 is like an upward opening parabola with a very flat bottom, and 2 to the exponential, and you're expected to see 2 points of intersection between that exponential and that flattened parabola. So what I want to do is I want to go to a graphing software, and I'm going to graph out two things. I'll tell you what I'm going to graph out over here. I'm going to graph this out. Let me change the color of it. I'll make it green. Close that out. And I see the exponential, right? That's the exponential. Now, why does it look so flat there? The scale is really off, by the way. What I mean by that, if you look at the abscissa, it's between about, minus 300 and 300. But the ordinate, I mean, it's really a huge number over here. It's, 10 to the 77. That's a huge number. So everything looks flattened down. The scale is off. All right? Let me show you this one over here. Let's take a look. Let's color it. And let's make magenta on that one. All right? Okay, looking at it, I'm seeing over here, let me close this out. Let me just blow this up a little bit. All right, I'm seeing over here a point of intersection. Now what I'm going to do over here, I'm actually going to zoom in to that region. So what I'm going to do is over here somewhere, I'm going to just do this over here, and I'm seeing a point of intersection over there. Now someone says, could you use software to figure out that point of intersection? I can, and let me do that now. And I'm going to go for a point of intersection over there. So let me just take a look, intersect. And I'm going to say that's around about 260. And what does it give me? It says the x is 256.0052. Now, certainly we've got a different number, but that's not a bad approximate. They're telling the y is a huge number over here. What did we get? Let's go back to what we did, whiteboard, 256. So again, it looks pretty good. All right, let me go back to what I would see if I were just graphing this thing out over here. Let me close this out. And what I want to do is I want to, recenter this at the origin. Let me just center at the origin. And what I want to do is I want to zoom into this region over here. All right. Now, as I do that, I need to change the scale. All right. So I equalize axis, center origin. Give it a second. I wonder what happened over there. Gee, I hope it didn't stop working. Well, go axis and see what happened over there. And let's edit. And let's go between, minus 5 and 5. Oops, not 55, 5. And let's do the ordinate. I must be seeing a region that's not even there at this point. Let's see, axis and grid. And ordinate, I'm going to go between, it's undefined, that's why. I'll do minus 2, and then I'll do 10. All right, so let's just emphasize what I'm seeing over here. Let me equalize axis, center the origin, and what I'm going to do is I'm going to zoom into this region over here. Right, this one, if I were doing a hand graph, that's what my hand graph would look like. Now, someone's going to say, could you get the point of intersection over there? I can. So what we're going to do is I'll go back to that equation, find intersection. I'm going to say it looks about 1.1. And we'll say 1.0277. I want to point out when we do Newton's method, we're going to get a very similar answer. It's right over here. All right, what I want to do is I want to do another one. I'll do the one, it looks about minus 1.1. And what do you get there? 0.9793. Are we getting that over here? Within reason, but we're getting that. Not exactly the same thing. These are kind of hard to determine, all right? So again, whoops, I want to go back to the, I have to recompile the problem again. I closed out the PDF. This is a huge document, by it's almost 1,000 pages. It's written in LaTeX, and what I'm doing is compiling the LaTeX right now. I just closed out the PDF. So we're back over here. So again, I want to point out, paper and pencil led to 256. But again, initially my idea was graphing it, was there was 2 points of intersection, very close to the origin, by the way. So I look at a picture of that. I'm going to use Newton's method to find those points of intersection. Thank you.